In this video, let's see an IIT JEE previous year question that was asked in the year 2013, that is 2013 main exam, and was based on the topic both inverse trigonometric function and sequence and series, that means the progression chapter of arithmetic progression and geometric progression. We already know that these chapters hold much weightage, especially the sequence and series in the IIT JEE examination. And a hybrid question involves the demand of knowledge of both the chapters' formulas. Let's see how to solve this question and let's get started with the solution. Let's first read the question together. The question says what? If x, y, z are in AP, what is AP? AP means arithmetic progression. And also given to me that tan inverse x, tan inverse y, tan inverse z are also in AP. Then what do we need to do? We need to choose one out of these four options. Either x is equal to y is equal to z, or 2x is equal to 3y is equal to 6z, or 6x is equal to 3y is equal to 2z, or last but not the least, 6x is equal to 4y is equal to 3z. Let's write the heading solution and let's get started with the solution. So, when I know that I have been given the knowledge of arithmetic progression, that means there are different terms and the common difference in these arithmetic progressions means that they should be same. That means if I have three terms A, B, C and it is given to me that these terms are in AP, that means what? That means the consecutive terms difference, that means the difference between B and A and the difference between C and B has to be same. So that means what? It means B minus A is equal to C minus B. Now, taking B's on the same side, different variables on the other side, I have B plus B, that means 2B is equal to C plus A or A plus C. So I have derived this relation for three terms in arithmetic progression, wherein 2 multiplied by the middle term, that means 2 multiplied by the second term, is equal to A plus C, that means the first term and the third term. So it is 1 plus 3. Now we will be using this concept that we have derived ourselves in the later part of the question. Let's use and apply this concept for firstly XYZ being in AP. If XYZ are in AP, what do I have? I know that twice of the second term is equal to 1 plus 3, that means twice of y is equal to x plus z. And this relation will be used, let's name it as equation number 1. Similarly, applying the same concept for tan inverse x, y and z, I again have 2 into the second term, that means 2 into tan inverse y is equal to the first plus the third, that means the tan inverse x plus tan inverse z. Now, obtaining this equation, I would be applying again some formulas. The formula of tan inverse A plus tan inverse B can be applied, which is what? Which is tan inverse A plus B upon 1 minus AB. This we have already seen and studied. Also, the formula of 2 tan inverse theta can be applied, which is tan inverse 2 theta upon 1 minus theta square. We have already seen these two formulas and we are just applying this. Now, what is the value of 2y? Can I substitute something in place of 2y? 2y is basically x plus z. So here when we have 2y, we can substitute it as x plus z. The rest story remains the same. Do not change the other values, just write them as it is. Now, can we manipulate the question further? First of all, x plus z is written from where? Not from our mind but from the equation number 1. So I write here from 1. And the other thing, tan inverse and tan inverse basically nullify and cancel each other. So what is left is x plus z upon 1 minus y square is equal to x plus z upon 1 minus xz. Now, x plus z also nullify and cancel each other. So basically what we are left with? We are left with 1 upon 1 minus y square is equal to 1 upon 1 minus xz. From where? From this step. Tan inverse nullify, numerator cancel. Now, can we cross multiply the above thing? Yes, we can. So it is 1 minus xz is equal to 1 minus y square. 1 cancels, minus cancels. So it is basically y square is equal to xz. Now when we again have derived something called as y square is equal to xz, can we not conclude that x, y, z are in geometric progression? Yes, we can, because this formula is applicable only when the three terms are in geometric progression. Now, when x, y, z are in AP, this was given to me. When x, y, z are in GP, this we have derived. So, does that not mean from these two things that my x, y and z have to be equal so as to satisfy these two conditions of AP and GP? So, yes, my x is equal to y is equal to z from these two conditions, and hence my answer to this question is x equal to y equal to z, which is option number A. For those who have still not understood as to why when two things are both in GP and AP, they have to be equal. So let's consider one example for the same. Suppose I have a series given to me as 4 and they are moving on till infinity. Now 4 or any other term is given to me. Where is the first term? It is 4 only, so it is A. What is the difference between any two terms? 4 minus 4 is 0. Here also 4 minus 4 is 0. So the difference is 0. What is the common ratio? Does there exist a common ratio? Yes, it does. Second term upon first term or third term upon second term that we check in GP usually is 1. Since there exists a common ratio, there exists a common difference. So this is also an example of AP as well as GP. That means the terms have to be same, which was here that terms are to be same, identical, they are to be equal. Hence, for any series wherein the terms are equal, they will be in GP as well as AP.